In this video, we will be discussing how to add and subtract radicals. So there's two questions that you're going to ask yourself. And actually, there's one question you're going to ask yourself, and you're going to determine your route based on if the answer is yes or no to this question. So first, you're going to look at the radicands, and you're going to determine, are the radicands like? So are they the same? Is the same number underneath the square root? If the answer is yes, then you're going to add the coefficients and keep the radicand the same. If the answer is no, the radicands are not the same, then you're going to ask yourself, can I simplify? If yes, then you're going to simplify and see if you can combine like radicals. So in order to be able to add and subtract radicals, they have to be considered like terms. So if we look at this first example, the addition example, first I'm going to look at, are the radicands the same? In this case, they are. They both have a 2. So I can go ahead and just add their coefficients together. Remember that coefficients are the numbers in front. So I'm just going to add 2 plus 4 to get 6, and then keep the radical the same. So we're just combining like terms. So the final answer would be 6 square root 2. In the subtraction example, again, I'm looking, are the radicands the same? So I have a 2 and an 8. They are not the same. So then the next thing I'm going to see is, can I reduce either one? So I know I can't reduce the square root of 2, but I know I can reduce the square root of 8. So I can reduce the square root of 8. So I'm going to go ahead and bring down the 4. And then I know the perfect square number that I can divide 8 by is 4 times 2. The square root of 4 is just going to become 2, bring down the square root of 2, and then since there's a 4 in front, I need to multiply the 2 by 4 to get 8 square root 2. And then don't forget to bring down the 2 square root 2 and this minus sign in the middle. So now that I've reduced everything, now I'm going to look and ask myself again, are the radicands the same? And in this case, they are now. So now I can combine them. So 2 minus 8 would give me negative 6 square root 2 as my final answer. So these first 4 examples are pretty easy because all of them, the radicals are the same. So we're just going to go ahead and combine them. So here, the radicals are the same. So I'm just going to combine the coefficients. 2 plus 3 is 5, square root 2. Final answer. In example 2, technically there's a negative 1 in front of the second square root. And again, because the radicands are the same, I can combine them. So I'm going to do 18 minus 1 to get 17 square root 5 as my final answer. Example 3, again, the radicals are the same, so I can just combine the coefficients. So negative 2 plus 5 gives me 3 square root 6. And then again, this next example, they both have the same radicand, which is 11. So I can do 4 minus 5 to get negative 1 square root 11. So let's try some of the more challenging examples on the next page. So in example 5, this time I have 3 terms, but notice they all have the same number underneath the radical. So technically in front of the last square root 7, there's a 1. So I'm going to combine all of my like terms. So 6 plus 4 plus 1 gives me 11 square root 7 as my final answer. Same thing with this next example, the negative square root 10s, those are negative 1s there. So negative 1 minus 1 plus 3 gives me positive 1 square root 10 when I combine my like terms. In example 7, I have 2 square root 6s, and then I have 2 square root 5s. So remember, we can only combine the like terms. So let's start with the square root 6s, and I'm going to combine 5 and 4 to get 9 square root 6. Plus, now I'm going to combine the square root 5 to get 6 plus negative 3 gives me positive 3 square root 5. And this would be my final answer because I can't add them since they have different numbers under the radical, and I can't reduce the square root of 6 or the square root of 5. Moving on to example 8. This one's a little bit more challenging because I have 80, 20, and 45. None of those radicands are the same, so I can't add or subtract any of them right now, but I think I'm able to reduce all 3 of them. So I'm going to go ahead and do that next. So the perfect square number that I can divide 80 by is 16 times 5. The square root I can divide 20 by is 4 times 5. And then the square root I can divide 45 by is 9 times 5. So for the first one, the square root of 16 becomes 4 square root 5. And then when I bring down that negative 3, I need to multiply negative 3 times 4 to get negative 12 square root 5. For the second radical, the square root of 4 just becomes 2, and then bring down the square root 5 and the negative 3, and then make sure you multiply the negative 3 and 2 together to get negative 6 square root 5. For the third radical, the square root of 9 becomes 3, bring down the square root of 5, bring down the negative 2, and then make sure you multiply negative 2 times 3 to get negative 6 square root 5. Now that I've simplified everything, notice now they all have the same radicand. So now they are all like terms. So I'm going to combine them. Negative 12 plus negative 6 plus negative 6 is negative 24 square root 5. And that's the final answer for number 8. Next example, number 9, again, I have 72 and 8, so I can't combine them, but I think I can reduce both of them. For 72, the number I can divide it by is 36 times 2. And the square root of 36 becomes 6 square root 2. For the square root of 8, I can divide that by 4 times 2. The square root of 4 becomes 2. And then bring down the square root 2 and multiply it by that 5 that's in front. So I end up getting 10 square root 2. And then I'm going to bring down the plus 6 square root 2. Now that they have the same number under the radical, now I can combine them because they are like terms. So I would get 16 square root 2 as my final answer for number 9. Next one, number 10, again, I can't combine them yet, but I can reduce the square root of 40 to 4 times 10. And then the square root of 4 becomes 2 square root 10. So I'm going to bring down negative 2 square root 10 minus 2 square root 10, and now they're like terms. So negative 2 plus negative 2 is negative 4 square root 10. Okay, last 2 examples. In number 11, I can reduce the square root of 12 to 4 times 3, and then bring down the plus 8 square root 3. The square root of 4 becomes 2 square root 3, and then bring down the plus 8 square root 3, and now they're like terms that I can combine. So I would get 10 square root 3 as my final answer. In this last example, I can reduce the square root of 45 to 9 times 5, which becomes 3 square root 5, and then I'm going to bring down the 3 square root 5 minus. Now that they're like terms, I'm going to combine them, and they cancel out. So if they cancel out, then you would just write 0 as your final answer. So again, the thing you need to remember about adding and subtracting radicals is you have to have the same number underneath the square root in order to combine them as like terms. Feel free to reach out to your teacher if you have any additional questions.